Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at quadratic and linear functions. Alright, so the question reads, a quadratic function and a linear function are graphed on the same set of axes. Which situation is not possible? Alright, so let's get started by talking about what the graph of a quadratic function looks like. Alright, so this is something that you should keep in mind. Which is as follows. The graph of a quadratic function, does what? The graph of a quadratic function turns exactly once. Okay? One way to know the maximum number of turns for any function is by looking at any polynomial function is by looking at the degree. Okay? So for the quadratic function, it turns exactly once since its highest degree is 2. All right? So a polynomial function turns one less than the highest degree. All right? So let's take a look at what the graph of a quadratic function looks like. You should notice this is basically the graph of a parabola. Okay? So let's just sketch it. So let's say we have a downward facing parabola. All right? If you have a downward facing parabolic function, it's going to look something like this. Bam. All right? So what this point that we are stating right here is indicating is that you're going to have exactly just one term for a quadratic function. And then if you have a linear function, guess what? Since the highest degree of a linear function is 1, you have 0 turns. Alright, a line just goes straight, it doesn't look back. Alright, okay, so this is a quadratic function. This is what the graph looks like with 1 turn. A linear function has 0 turns. Okay, so what we're going to be considering in this example is basically how many. So this is an example of a linear function with no terms. So how many, which of these scenarios is not possible? All right, we're going to be taking a look at an intersection between a quadratic function and a linear function. So the first option, it says the graphs do not intersect. Think about that for a second. Is it possible for a linear function or quadratic function to have no intersections? The answer is yes, it's possible. All right, let's take a look at an example scenario. If you have let's say a quadratic function that opens up and the linear function is on the other side of the opening and does not intersect. Okay, so let's say you have a line like this. Bam. So if a quadratic function opens in the other direction of the position of the line and doesn't touch the line, you're guaranteed to have no intersection because this quadratic function does not turn more than once. It keeps going up forever to the left and forever to the right, and this linear function will always be beneath it. All right, so this is possible. Makes perfect sense. Now let's move on to the next one. It says the graphs intersect at one point. Is it possible for a quadratic function and a linear function to intersect at exactly one point? Absolutely. This is possible. All right. When does this happen? This is the case when the line is tangent to the quadratic. Okay, to the quadratic. What does tangency mean? Tangency basically means that the line touches the curve at exactly one point. So let's say we have a quadratic function like this, and let's say this point right here is a point of tangency. That means that the line is going to touch the quadratic function at exactly one point of tangency right there. Bam. So it's possible. This makes perfect sense. Okay. And then number 3, the graph intersects in 2 points. Is that possible? Think about it. Is it possible for a quadratic function and a linear function to intersect twice? Absolutely, this is possible. All right, can you visualize what that looks like? Yeah, instead of a tangent line, it's going to be a secant line, right? Basically, look for a line, the line uh, drawn in such a way that it cuts the quadratic twice. Cuts the quadratic twice. Can you draw a scenario like that? Certainly. So if you have a quadratic that opens upwards, just raise the line high enough so that it's higher than the point of tangency, right, towards in the direction of the opening, and that will suffice. So you just have a quadratic right here, bam, and you have an intersection point right here and an intersection point right here. So this is absolutely possible. Okay, so based on elimination, we have four choices. We automatically know that the answer has to be option 4. Okay, it says the graph intersects in 3 points. So is it possible for a quadratic to intersect a line 3 times? The answer is no, it's not possible. That cannot happen. All right. In order for this to happen, the parabola has to turn twice. Okay, so the parabola, or let's call it the quadratic so that we're consistent here. So the quadratic graph, the quadratic must turn twice for this to happen. But what do we know based on what we stated earlier? Graphs of quadratics turn at most once. Okay, so quadratic um, graphs quadratic graphs do not turn more than once. Do not turn more than once. Okay, so you have, let's say you have a line, okay, and a parabola comes down and cuts it, yeah, and it turns once, cuts it again. It cannot turn more than that. All right, that's it. If it turns like this, it's no longer a quadratic function. This is a cubic function. All right, so as long as it's a quadratic function, you're turning only once, and that results in a maximum of 2 intersections. All right, so this particular question might be similar to something that you have considered in the past, which is basically the number. This question is the same thing as asking the number of real solutions, for a quadratic, right? You can use a discriminant to do this also. So if you're looking at a quadratic equation, how many solutions do you think you can have? Just a real quick review. You can either have you can have no solution, okay, no real solution. In that case, you have no intersection, just a quadratic and a line. You have no solution, case 1. In this case, the discriminant is negative. You can have exactly one real solution. Remember this in the quadratics unit. One real solution where you have a graph of a parabola and the line is tangent to it. Bam. Oh, you know what? Let me fix my first graph. Because when we're looking at solutions here, the line has to be a horizontal line. Alright, so let's fix that. Alright, so no solution right there. And the last case is where you have 2 solutions. Okay, so either the parabola is strictly above or beneath it. And then in the last case, where your discriminant is greater than 0, you have 2 real solutions. So the question of the number of real solutions for a quadratic and the number of intersections between a line and a quadratic graph? That's exactly the same question. Okay, the number of intersections is the number of real solutions that a quadratic function has. All right, maximum of 2, minimum of 0. Okay, so you can either have no intersection, one intersection, or 2 intersections, and that's that. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. Tons of support resources can be found on mathgotserved.com. Do check it out. If you have any questions, comments, or you want to let us know how your day is going, just specify it in the comment section below. I'll be glad to respond. Thanks again for watching, and we'll see you in the next video. Goodbye.